We're going to switch to Thomas Petit, researcher at the French National Institute for Audiovisual Archives, who is going to make a live demonstration of your new face recognition and management tool. I believe the floor is yours, Thomas.
Yes, I'm going to do a live demo of Trombinos, which is the face recognition solution and also the face image database management tool that we developed at IFTA in the last 2-3 years. So I'll mainly do the demo from a user point of view, and then at the end I'll go, if you want, I will go a bit more on the algorithm and the technical side. So the goal of this application is to help the archivist to better, more quickly annotate recognize the faces in our TV shows. And so the theories we have at INA, it contains at the moment 1 million identities. So that's a large number, and we are not able, of course, at the moment to recognize them all, because we do not have a reference image for every one of each one of those persons. We have a reference image for at the moment for 70,000 people, and so I will show you then how we are able to increase that number manually, and how we can correct the few errors that might have appeared in the building of our dataset. So also we have analyzed 365 hours of videos that have been broadcast between 2010 and 2020. We extracted from those videos 500 million images, keyframes, in which we detected the faces and we analyzed them. So that's 600 million faces that we detected in all of those videos. And for the moment, we have identified a bit more than 10% of those frames, so that's 63 million faces. Okay, so we have identified them with the 70,000 identities for which we have reference images. Okay, so I'll show you how we analyze one image with an example here. So the image here, that's a picture of the candidates of the previous presidential election in France 5 years ago. So here's the analyzed image. So every detected face is appearing in the white square, and the currently selected face is in the blue square. So we have some information here. So those informations, we compute them using an off-the-shelf model that we took from IBM, I believe. So we're not doing anything with this at the moment, but maybe in the future we'll try to exploit this more in depth. What's really interesting is on the right-hand side. So here we have the probable identities of the faces that we detected with a confidence score. So when the face is easily recognized, as it's a case here, we have only one candidate, but we can have multiple proposals for each face. Okay, so here you see for Jean-Luc Mélenchon, so we have the correct proposal, but we also have another candidate, another identity, which is proposed, which is not Jean-Luc Mélenchon, but with an image of Jean-Luc Mélenchon. So we'll come back to this later, and we'll see how we can correct this, so that our model does not make this same error in the future. Okay, so if I open the page of Jean-Luc Mélenchon, so we have some metadata about him. Some of them have been scrapped from Wikidata, and we can see the pictures that have been assigned to him. So we have 19,000 images of him, And you can see some of them have that little yellow icon, and other ones have a green icon. So the yellow icon is the images that have been assigned to that person automatically by our model, and the green icon corresponds to the images that we have validated, that have been validated by a human user. So we can validate manually the images, but of course you'll tell me that 19,000 images, that's a lot to annotate manually. So we can cluster the images to regroup them, to gather them by similar looking faces, and this way we can validate them together. So here you see we have this cluster of 800 images, so I can open it to check if it's really him in the images. And once I'm sure that's him everywhere, so I can validate the image, and now I have validated all those 800 images for Jean-Luc Mélenchon. Now I can also go directly to the videos in which we detected, we identified him. So of course that's someone who is quite well known. So we have many videos for him. So we can open the one video and we can play them. Okay, so I don't know if you get the sound, but we don't need it actually. So. So here we have the video player. Below we have some metadata about the program. And what you can see on the right-hand side, this is a timeline, which is a timeline of the video with the timestamps at which some people have been identified and recognized. So for example, here, if I click here, we can see Yvan Rioupeau, which is that guy here. So like this, we can easily get to the part where Jean-Luc Mélenchon is the one talking, or find someone else. And we can also run an analysis on the current frame to detect and recognize the faces that are on the current frame. So yes, we need to change that a bit because it's not easy to read, but that way we can go anywhere in the video and run the analysis. So it takes a few seconds to recognize to run the analysis on the frame, but so you get the idea. Okay, so that's how you browse and you can find images for someone and find the programs in which he appeared. Now let's have a look when we have some mistakes and we need to correct them. So this is supposed to be the page for André Ticot-Dicola, which is supposed to be a journalist. And as you can see, it's been assigned wrongly with only images of Jean-Luc Mélenchon. So that's not cool because then we won't be able to recognize André Ticot-Dicola when he appears. And it might also pop as a result when we are in fact trying to recognize Jean-Luc Mélenchon. So here we can invalidate all of those faces in one click, okay? And now the thing is that we have no images, so we're still not able to recognize him. So we have several ways to do this. So the basic way is to simply, if we know who he is, to simply upload an image that we have somewhere. With a URL or to upload an image that we have locally. We can also scrub, for example, Google or another search engine. And from the result, we detect the faces, we group them together. And this way, if we know who he is, we can maybe try to find it again. But my favorite way to identify someone is this one. So here we will sample multiple videos in which our man has been labeled. And we will detect all the faces in all of these videos, and we will compare them to each other to try and find the one face that is appearing in all of those videos. And this way, that's a very efficient way to have that face emerge from all of those videos. So we need to have someone that appeared in at least 5 videos for it to work, because if you only appeared in 2 or 3 videos with many other people, it's much more difficult. But so here, you can see that we have a large cluster of one man in several shows, and so I prepared this earlier, so I know that's him. So we can validate it easily like this. And now he has been assigned to Andreas Ipodicola, so we can add his image here so that we can recognize him later. And like this, we have 100 images for him, but maybe we can find more. So we can look for similar looking faces in our data set. And so it takes a bit of time because we have a lot of images. And then we'll be able similarly to add the images by cluster. So here you see we have a cluster of 8,000 images. So maybe we can open it, check that's him. And if it's really him in all of those images, then we'll add it to that person. Okay, so it seems all right. So I'll add it. Okay. It takes a bit of time, but then we'll have 8,000 images for this month, for which we had no images just a couple of minutes ago. So now, once again, we can go and videos tab and find where he appeared and see. Okay, so the timeline where the images are, where the name of the people recognized are appearing. This is done offline, so we need to actualize it to see it appearing again. But this way, so we have the videos in which happen. Okay, what else? So we can also look for people directly by name, like this. We have filters if you want to filter. If we're looking for someone in particular, we can filter by the date of birth, by the occupation, or something like this. Okay, so here, let's see, we can add some images to him because this well known. Okay, and okay, and we can also look for videos. Let's say if we're looking for program in particular. So, okay, let's say we open it, and if we're looking, so in a show in particular, we can see it and run the analysis on the frames directly. So yeah, that's it. About the algorithm side and the technical side, so the face recognition model, this is a model that we trained ourselves 3 years ago. I think it was quite close to the state of the art 3 years ago. Now we could probably use a more accurate model, and we're working on this because just as you, Tim, as you said before, we also have issues with people who are not white and between, say, 20 and 70. So we're working on training a new model that will be more accurate for other people, for Black and Asian faces, to have better results. So other than that, so yes, we detect, we align the faces in the images. We extract a 128 dimensional descriptor, which is indexed in a database. And for the classification part, this is a k-nearest neighbors based classification. So we look at the most similar looking faces in our database that have been already labeled, and then we aggregate the labels of those KNNs. On the architecture of the application, so I'm not the expert here, but if some of you are interested, this is the structures of what we're using. Yes, so we're using, for example, face for the KNN search for being able to find similar vectors on a large scale. And okay, if you have more questions about this, you can ask this at the end, and then I'll answer you. And yes, that's it. All right.
Thank you, Thomas. Very interesting presentation. It's a very sleek looking tool that you have there. I really like how you have the about, all the information you needed for the presentation that is included in the interface. That's very nice. For those of you joining us in the middle of the session, please ask your questions in the Q&A tool, and we will be answering all the questions in batches after the last presentation. So thank you again, Tama, and now we will be